Diversification is a factor used to reduce the total load on an electrical service based on the assumption that not all connected loads will operate simultaneously. For residential package terminal air conditioner or TAC units, the National Electrical Code or NEC allows specific diversification factors. Understanding these factors is crucial for efficiently sizing the electrical service. When dealing with continuous loads, the NEC typically requires accounting for 100% of the total load. However, for non-continuous loads, where the usage is intermittent, diversification factors can be applied. If they are less than 50 units, a diversification factor of 50% of the total load can be used. For installations with 50 units or more, the diversification factor drops to 40% of the total load. Now, let's apply this to a scenario involving the installation of 100 TAC units, each with a power rating of 2.9 kilowatts. Total load can be calculated by multiplying the number of units by the power rating of each unit. In this case, it's 100 units times 2.9 kilowatts per unit, resulting in a total load of 290 kilowatts. To determine the appropriate service size, the permissible diversification factor must be considered. Since there are 100 TAC units, which is more than 50, the diversification factor for non-continuous loads is 40%. To calculate the diversified load, multiply the total load by the diversification factor. In this scenario, it's 40% of 290 kilowatts, which equals 116 kilowatts. Therefore, the electrical service should be sized to handle a load of 116 kilowatts. It's important to note that diversification factors are based on typical usage patterns and may vary depending on specific conditions. Factors such as occupancy patterns, climate, and building usage can influence the actual load profile. Always consult with a qualified electrical engineer or inspector to determine the most appropriate diversification factors for a given installation. The NEC provides guidelines for electrical installations, promoting safety and standardization. Adhering to these guidelines is essential for ensuring the safe and reliable operation of electrical systems. Proper load calculation and service sizing are crucial for preventing overloads and voltage drops, which can damage equipment and create safety hazards. In summary, the permissible diversification for sizing the service for 100 TAC units, each drawing 2.9 kilowatts, is 40%, resulting in a diversified load of 116 kilowatts. This value should be used to determine the appropriate size of the electrical service. However, always consult with qualified professionals to account for specific conditions and ensure compliance with local codes and regulations. Accurately calculating electrical loads is essential for designing safe and efficient electrical systems. Diversification factors play a vital role in optimizing service sizing, reducing costs, and improving overall system performance. Remember that these calculations are based on the information provided and the NEC guidelines. Actual installations may require additional considerations and adjustments based on site-specific factors. It's recommended to consult with a licensed electrical engineer to ensure that the electrical service is properly sized and installed in accordance with all applicable codes and standards. By following these guidelines and seeking expert advice, electrical systems can be designed and installed to provide reliable and safe power distribution. The NEC provides detailed information on load calculations, wiring methods, and overcurrent protection, ensuring the safety of people and property. Keeping up to date with the latest edition of the NEC and any local amendments is important for all electrical professionals. Understanding the principles of load diversification is just one aspect of electrical engineering. There are many other factors to consider, such as voltage drop, conductor ampacity, and short-circuit current calculations. A comprehensive understanding of electrical theory and practice is essential for designing and installing safe and efficient electrical systems. Continuous education and professional development are vital for staying current with the latest technologies and industry best practices. The field of electrical engineering is constantly evolving, with new innovations and advancements emerging all the time. By embracing lifelong learning and seeking opportunities to expand knowledge and skills, electrical professionals can remain at the forefront of their field. Proper electrical design and installation are crucial for the safety and well-being of building occupants. Electrical hazards can cause fires, shocks, and other injuries, so it's important to take every precaution to ensure that electrical systems are installed and maintained properly. Regular inspections and maintenance can help identify and correct potential problems before they become safety hazards. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. By following safe work practices and using appropriate personal protective equipment, electrical workers can minimize their risk of injury. The public can also contribute to electrical safety by reporting any potential hazards to the appropriate authorities. In addition to safety, energy efficiency is another important consideration in electrical design and installation. By using energy-efficient equipment and implementing energy-saving strategies, building owners can reduce their energy consumption and lower their operating costs. Energy-efficient lighting, HVAC systems, and appliances can all contribute to significant energy savings over time. Smart building technologies can also help optimize energy usage by automatically adjusting lighting and temperature based on occupancy and other factors. Sustainable electrical design is becoming increasingly important as building owners seek to reduce their environmental impact. By using renewable energy sources, such as solar and wind power, buildings can generate their own electricity and reduce their reliance on fossil fuels. Green building certifications, such as LEED, provide a framework for designing and constructing environmentally friendly buildings. The future of electrical engineering is likely to be shaped by emerging technologies such as artificial intelligence, the Internet of Things, and electric vehicles. These technologies will require new electrical infrastructure and systems, creating opportunities for innovation and growth. Electrical engineers will need to adapt to these changes and develop new skills to meet the challenges of the future. The electrification of transportation is another major trend that will impact the electrical industry. As electric vehicles become more popular, there will be a growing demand for charging infrastructure. Electrical engineers will play a key role in designing and installing charging stations, as well as upgrading the electrical grid to support the increased demand. The development of smart grids is also transforming the electrical industry. Smart grids use advanced sensors, communication networks, and control systems to improve the reliability, efficiency, and security of the electrical grid. Smart grids can also enable the integration of renewable energy sources and allow consumers to manage their energy consumption more effectively. The increasing use of data analytics is also changing the way electrical systems are designed and operated. By analyzing data from sensors and other sources, electrical engineers can identify patterns and trends that can be used to improve system performance and prevent failures. Predictive maintenance techniques can also be used to identify equipment that is likely to fail, allowing for proactive repairs and preventing costly downtime. Cybersecurity is another critical consideration in the electrical industry. As electrical systems become more connected, they are also more vulnerable to cyber attacks. Electrical engineers must implement robust cybersecurity measures to protect critical infrastructure from malicious actors. The development of new materials and technologies is also driving innovation in the electrical industry. New types of conductors, insulators, and other materials are enabling the design of more efficient and reliable electrical systems. Nanotechnology is also being used to develop new electrical components with enhanced performance characteristics. The field of electrical engineering is constantly evolving, and there are endless opportunities for innovation and growth. By staying current with the latest technologies and industry trends, electrical professionals can make a significant contribution to the advancement of society. Proper planning is essential for the successful installation of any electrical system. This includes conducting a thorough load calculation, selecting the appropriate equipment, and developing a detailed installation plan. The installation plan should include a schedule, budget, and list of resources. Communication and coordination are also important for ensuring a smooth installation process. The project team should include representatives from all stakeholders, including the building owner, electrical engineer, contractor, and utility company. Regular meetings should be held to discuss progress and address any issues that may arise. Safety is always the top priority during electrical installations. All workers should be properly trained and equipped with the necessary personal protective equipment. The worksite should be kept clean and organized to prevent accidents. Electrical work should only be performed by qualified and licensed electricians. After the installation is complete, the electrical system should be thoroughly tested to ensure that it is operating properly and safely. Testing should include voltage measurements, insulation resistance tests, and ground fault impedance tests. Any deficiencies should be corrected before the system is put into service. Regular maintenance is essential for ensuring the long-term reliability and safety of electrical systems. Maintenance should include visual inspections, cleaning, and testing. A maintenance schedule should be developed and followed to ensure that all equipment is properly maintained. Records should be kept of all maintenance activities. Troubleshooting electrical problems can be challenging, but it is an essential skill for electrical professionals. A systematic approach should be used to identify and diagnose the problem. The first step is to gather information about the problem, such as when it occurs and what symptoms are present. The next step is to use a multimeter or other testing equipment to identify the source of the problem. Once the problem has been identified, it can be repaired or replaced. Electrical safety is a critical aspect of any electrical system. It is important to follow all safety precautions when working with electricity to avoid injury or death. Some basic safety precautions include wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It is also important to energize electrical circuits before working on them. If you are not qualified to work on electrical systems, you should always hire a licensed electrician to do the work for you. Electrical codes and standards are designed to ensure the safety of electrical installations. It is important to be familiar with the applicable codes and standards when designing or installing electrical systems. The National Electrical Code, or NEC, is the most widely used electrical code in the United States. Local jurisdictions may also have their own electrical codes and standards. It is important to consult with the local authorities to determine the applicable requirements. Electrical engineering is a challenging but rewarding profession. Electrical engineers design, develop, test, and supervise the manufacturing of electrical equipment, such as electric motors, power generators, and lighting systems. They also design and develop electrical systems for buildings, transportation systems, and communication networks. Electrical engineers work in a wide variety of industries, including power generation, telecommunications, aerospace, and manufacturing. To become an electrical engineer, you typically need to earn a bachelor's degree in electrical engineering. Some electrical engineers also pursue advanced degrees, such as a master's degree or doctorate. Electrical engineers must be licensed in order to practice in many jurisdictions. The licensing process typically involves passing an examination and meeting certain education and experience requirements. Electrical engineering is a constantly evolving field. Electrical engineers must stay up to date on the latest technologies and trends in order to be successful. There are many opportunities for electrical engineers to specialize in a particular area, such as power systems, control systems, or communications systems. The demand for electrical engineers is expected to grow in the coming years. This is due to the increasing demand for electricity and the growing complexity of electrical systems. Electrical engineers are needed to design, develop, and maintain the electrical infrastructure that powers our modern world. The 40% diversification factor applied to the 290 kilowatt total load yields a diversified load of 116 kilowatts. This diversified load is the value to use when sizing the electrical service for the 100 PTAC units.